today, we learned about the various parts of the nephron. Yeah? From top to end, how blood flows and how the filtrate flows. Okay, so can we do a quick recap? For all of you here, you can quickly go and have a look before we start. Okay, what are all the names of the parts? After that, without referring, we're going to try. Okay, then you can choose up. So there is this structure here. B, C, D, E, F. Okay, other than that, I'm going to draw in purple all the blood vessels. We have one arterial branching in, branch out into a lot of capillaries. What is it called? Then you branch out into another arterial. This blood vessel will then branch out into lots of capillaries. What do we call all these capillaries on top? And after that, the capillaries will go downwards, go upwards, and then they'll reform to form the vein. So what do we call those blood vessels below? There is A, B, C, D, E, F, G, E. What am I doing? What's after G? H, B, C, D, F. I need to sing a song, my friend. I, J, K. Ready? One more minute. Okay, you hope you get called first, then you can pick anything you want. Wow. I'm just staring blankly behind you. The error. Okay, close your books. Try your best. Just use hardcore memory. Choose whatever you want. Okay, we start with Ijat. Anything you want. Okay, thank you. B is the PCT. Okay, good. Proximal. Okay, the word is convoluted tubule. Not proximal complicated tubule. Okay? Proximal convoluted tubule. Thank you. Teacher, you choose another person. Who? Zhixuan next. H is a glomerulus, okay? Zhixuan, inside the glomerulus, does it carry blood or does it carry filtrate? Okay, you need to be more confident. Capillary carry blood. Okay, so this is the glomerulus. Thank you. Carry blood. The blood will get filtered, then it will enter into A. Yeah? Okay, Zhixuan, choose someone else. Ziwei. F is the collecting duct. Okay, good. This is the collecting duct. Ziwei, next, pass to someone else. Alpha. Okay, Alpha. There are many options here. Not any of them themselves are very terrible. The urea. Oh, you weren't here. Oh yeah, sorry, you were at nationals. Okay. Then you pass it on. Iran. Descending. There's a clue, it's a loop. Okay, good. Descending loop of Henley. Thank you. Okay, Iran, next. Pass it somewhere else. Who? Shabika. What do you want? K. Okay, thank you. K is the vasa recta. Okay, then Shabika. Vasa recta, does it contain urine, filtrate, or does it contain blood? Blood, good, huh? Okay, next. Pass on. Who? Henry, yeah. Henry, go.
It's like artery.
But you were there supporting also,
Yeah.
Wonder like nothing. Okay.
Yeah.
Pass it on to someone else.
Um,
I'm sorry, all of you all never.
oh yeah.
Although you all missed the lesson, why you do that? You also know he was there with you, right?
Yeah.
Okay, for all of you that missed the lesson, you better go and rewatch the video, okay? Okay, I'm not going to spend extra time on the three of you, okay? Okay, so why do you pass to him? You also don't be clueless. Pass someone else. What's up with you, man? Okay, never mind, stop it. See? Very good. Okay, this is the apron. There's a full name, it's arterial. Okay, Sissy, pass someone else. Tara. Then what's the I? Okay, so I pronounce it as apron, apron. Okay? Okay, Tara, next, pass someone else. Okay, Rohit chose this, ascending loop of Henley. Rohit, ascending loop of Henley, carry, filtrate, or blood? Sorry? Your filtrate comes out through here, then it will flow through the PCT, down the loop of Henley, go up. So it contains filtrate, not blood. You must differentiate these two. Can see or not? Okay, so at the glomerulus is where blood is filtered, and all the filtrate will come out into the A. From A, it will flow down the PCT, flow down the loop of Henley, go up the ascending DCT collecting duct, then out of you. Yeah, so it shouldn't contain blood unless you are peeing blood. Yeah. Okay, next, Rohit, pass someone else. Wednesday. Very good, thank you. I can finally say what it is. Okay, this is the Bowman's capsule. Okay, combine the Bowman's capsule and the glomerulus together. There's a name. What is it called? Okay, it's called the renal corpuscle. So these two combined, that's what it's called. Okay, Wednesday, next. Okay, now. E is the distal convoluted tubule. Okay, and next person. Oh, you just passed along. Okay, Zuni. Joy? You only have one option left. What is J? What are these capillaries called? Yeah, I already said already. But it does start with a P. P is like da 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 da. Yeah. Okay, it's the peritubular capillaries. Okay. So what we expect you to know are all the names of these parts. And you must know which part blood takes, which part filtrate takes. The moment you mix up these two, you either pee blood or you are carrying urine in your blood vessels. Okay? So please differentiate the two. After that, we spent quite a lot of time talking about the structure of the renal corpuscle. And we talked about the layers of filtration. So that's another part expected of you, the layers of filtration. This image up there is a very classic image that we like to show to test your understanding of where all these layers of filtration are. Now erase this.
Wait, what's DCT?
Distal convoluted tubule. Okay, then we focus our attention on the renal corpuscle. When we zoom into the renal corpuscle, this is what you see. So now let's blow this up. This is the side view. Okay, we learned yesterday that the blood vessels going in the afferent arteriole will branch out into a bunch of capillaries. Then after it will exit again via the efferent arteriole. Okay, what are the layers of filtration that we learned yesterday? Filter number 1, the blood vessels. Remember? The glomerular, capillary, have holes. What do we call those holes? Start with F1. Fenestrations. Fenestration is just another name for many holes. Okay? That's the first layer of filter. Ensures that you don't pee out blood. Okay? These small holes allow, so this is what the capillary will look like. The capillary has many small little holes. It allows liquid and small things to pass through, but not giant red blood cells and proteins. What is the next layer? The black one over here. Starts with a V. There are two parts to it. Something membrane. Okay? This is the basement membrane. Or your textbook they write as basal lamina, also can. And then we learn that beyond that, there are very specialized cells that have very long finger-like projections. What are these cells called? Starts with a P. What you say? Hey, don't anyhow spot stuff. Confusing it. Okay. These cells are called podocytes, but they form the third layer of filtration, called filtration slits, formed from interlocking pedicels of podocytes. Okay, that's filter number 3. And then there's one more filter. Okay, this last filter is the membrane in between the pedicels. Keep them from flying away, right? Also has membrane in it, right? It starts with S, then after membrane. What membrane is this? You look in your textbook, there's one page that shows you all the layers that's labeled. See it or? Last layer, between all these pedicels, you find another layer. We call it a slit membrane, because this membrane is what's in between all the slits. 4 layers of barriers in total. All of them work together to carry out a process called ultrafiltration. You've heard of the word filtration. Filtration is really just to make sure small things pass through, big things stay behind. Ultra is referring to the nature that we are filtering very small things, ultra small things. So okay, that's why we call it ultra. That's why we call it ultrafiltration. This is a very important process because once ultrafiltration fails, you end up having big things exiting into your filtrate. Yes? Yeah, okay. Good question by teacher. She asked, out of the 4 barriers of filtration, right, is it possible that only some of them work? It's possible that only some of them work, but if you do not have any one of these 4, you find that your ultrafiltration will not work very well at all. Some of the symptoms that your ultrafiltration is not working well is if the big things can start to pass through. Okay, so then begs the question, what is able to pass through into the Bowman's capsule, and what stays behind inside the blood? Okay, let's discuss this. What stays? What passes through? Want to make an educated guess? What should stay inside the glomerulus? Sorry? Yeah, okay. Your red blood cell need to stay inside your glomerulus, yeah? If not, you be blood. But actually, that is a symptom. If any one of these filters fail, actually you will start being blood. Okay? For example, these fenestrations, if the hole becomes too big, blood can start to come out. If these podocytes get damaged or they unstick themselves, blood will also start to come out. Okay? So that's why we are learning about all these layers of filtration, because the moment any one of these filters fail, it stops working. Things that you want to keep inside ends up coming out. Okay, other than red blood cells, number 2, you often find proteins. Proteins are quite big and they tend to stay within your capillaries. They shouldn't come out into your urine. But then, yes, Minya, actually you asked a question as well.
Yeah, then if kidney stone, then it's like cannot.
Okay, where will kidney stones form? Kidney stones will not form inside your capillaries. This is where they form. They can start to form, they do not form here, they tend to form at your ureter. So, yeah, this is your kidney. This is your ureter coming out. Kidney stones form here. Okay?
It's not hard.
They tend to form if you don't drink enough water. You're not in chemistry, right? To form crystals, all you have to do is you have a saturated solution, correct? Alright, the same thing happens in you. If you do not drink enough water, your urine becomes a saturated solution. It starts to crystallize in your ureter before you even pee it out. Okay? And I want to show you what kidney stones look like. Kidney stones actually look like crystals.
My father got kidney.
My entire family has kidney stones lah.
Then you better take care of yourself. You see kidney stone quite pretty, they look like crystal. Okay? The urea inside your urine, if you don't drink enough water, can crystallize. I tell you, what I thought kidney stones look like, right, were pebbles. But no, look at this, can you imagine how painful it will be, right? This crystal inside your ureter trying to come out. Can you imagine it gets stuck in your ureter? Worse still, stuck in your urethra. As you're trying to pee out, it gets clogged there. You'll be very, very, very painful. You may be thinking how to get it out there. 2 ways. One is via surgery. You need to go all the way in, cut and then get the crystal out. But number 2, you could take medicine to dissolve these crystals. Okay? But if the crystal is too big, you cannot dissolve it away.
So you can pee it out.
Correct. So if the crystals are small enough, you take enough of that medicine to dissolve it and it becomes smaller, you can pee it out. Okay? But it can be a bit painful to pee out. Not a lot from speaking of experiences, from anecdotes. Yeah? Yeah. Okay, it can clog until you cannot pee. It can clog your ureter. Then the urine don't end up into your bladder. Your kidneys start to fall sick. Yeah. If it clog the urethra, then you cannot pee out your bladder. The urine cannot come out. Okay. So must drink a lot of water. Everyone drink some water now. Okay, this is not a sign for toilet break. Okay, but if you need to go to the toilet, please go. But you're not allowed to go and refill water. Okay, go and do that later. Okay, but if you have a water bottle now, go and drink some water. Then what should pass through through into your filtrate. What do you think will pass through into the filtrate? If red blood cell and protein stay behind, what will pass through? Okay, number one thing that will pass through, urea. Make sense? Because that's what you want to get rid of, right? You find a lot of other metabolic waste. All these metabolic waste you want to get out. Number two, anyone pee dry pee before? Exactly how young one. Ask me what's dry water, I also know what it is. Huh? Okay, water. Water is what you should pee out. Number three is not what you expect. You actually will end up in this filtrate. Okay, here's the thing. This filter is very good at filtering big things. Make sure big things stay behind, small things pass through. But you know what else is small? Things like the nutrients that you absorb, like glucose, your amino acids, actually all your nutrients, right, will end up getting filtered and will go inside your nephron. Isn't this weird? You work so hard to digest and absorb the nutrients, then you go and pee it out. What do you think now? What can we possibly do to ensure you don't pee out? Don't pee out the useful stuff. Even though the useful stuff is actually entering the nephron. What could we do? Sorry? Okay, Kira is right. Do you notice just now, there were a lot of capillaries surrounding the nephron? Yeah? Those capillaries are there to help to reabsorb all the nutrients. Okay? Then I say again, all the capillaries you saw over there just now, where was it? Oh, no, let's just look at the textbook. Hey, where is it? Here. Okay, we look at this diagram over here. The reason why there are so many blood vessels surrounding the nephron is so that we can reabsorb back all your useful things. So that you don't end up peeing out glucose and amino acids. So it is a misconception to say that only the bad stuff gets filtered out. It is not true. The good stuff also filters out. So what's more accurate is that only small solutes pass through. That is more accurate. It is the small things that passes through. Good or bad. But the good stuff we will reabsorb back into our blood. The bad stuff we will let it out through urine. This is all important information because it helps tell you whether your kidneys are healthy or not. Do you know that, have you all went for a health checkup before when they ask you to pee into a cup? They ask you to pee into a cup because they want to check the health of your kidneys. You can check the health of your kidneys by checking what's inside the urine. If, for example, you find that there's blood in the urine or proteins in the urine, it means to say that some of your filtration barriers are spoiled. What are signs that there's blood in your urine? Okay, your urine will look reddish up. But if your urine is a kind of always yellowish one, then how you tell whether there's blood or not? Actually, you can still tell one. The urine will end up looking a bit brownish. If you mix red and yellow, you'll look a bit brownish. If your urine is normally those clear kind, then you'll see bright red. How do you tell there are proteins in your urine? Sorry? What do you say, Kara? Correct. Kara is right. Actually, there's protein inside your urine. you will find that the urine look a little bit bubbly and foamy. Any one of your urine here, foamy in nature, it will mean that there's a lot of protein inside. It could mean that your filtration barriers may not working very well. Yes?
Urine test.
Can scan. Okay. I'm just suggesting things that you can use with your eyes.
Oh.
Yeah. I don't expect any of you to have a kit at home to perform urine test. Okay. What if your nephrons don't reabsorb the useful stuff? It is also a sign that your kidney is not working well. Your urine sample may end up having a lot of glucose and amino acids. Those are useful things. It's a sign that your kidneys are not working anymore. Today, the scope of today's lesson, we're going to look at one more factor that's very important to allow you to filter blood. Let's go to B, and let's go to part 2. We're going to do a demonstration now in the remaining time. May I get everyone to read this first? This quick introduction.
Mr. Tan,
Yeah.
is the basal membrane phospholipid?
Oh, good question. What is the basal membrane made up of? It is not made up of phospholipids. It's made up of something called glycoproteins. Made up of a little bit of sugar and proteins.
So don't have.
It's not made of phospholipids. Okay, everyone give this part a quick read. Then we'll go into our demonstration soon. Okay, I'd like you to read this entire page first up. I'm going to go and collect some water. I'll be right back. Right now, okay, so we are done with one aspect. We know that if we want to filter your blood, we need to have filtration barriers, right? Okay, but next thing, if we want to filter your blood, we technically need some force that's forcing the blood through, right? The blood will not go through these barriers without any force. This is the next part of our lesson. The force that we're talking about, we call it hydrostatic pressure. Simple layman term, hydrostatic pressure just refers to blood pressure. Okay? Where does this blood pressure come from? Your heart. You're right, your heart. Every time your heart squeezes and contracts and pumps, there is blood pressure. And a little bit will be forced through this membrane. But the problem here is that when you force liquid through many layers of filter, you find that the pressure will start to decrease. A lot of energy has been dissipated as it passes through the filters. We need to find a way to ensure that the pressure going through the filters is always high. This next part of the demonstration, I'm going to show you how our Bowman's capsule, how our renal corpuscle is able to do that. Could I get 2 volunteers for this demonstration? Okay lah, Alpha. Thanks for volunteering, Alpha. Then Hao Yang, you will be the next one. Okay, Hao Yang, both of you. Okay, let's work with. Let me think. Here I want to punish more. Okay. Okay, Alpha, you come first. This will get a little. Okay, we're going to go outside for the demonstration instead. Some of y'all can be at the window, some can come out and squat down, but I think it's better outside. Afferent. Okay, so this tube right before the holy part, there's the afferent arteriole. This section onwards is the efferent arteriole. Okay? This short section here is just representing the fenestrated glomerulus. Okay? So what will happen if alpha uses a squeeze? Okay, alpha you squeeze, then our channel here. We go squeeze. Squeeze. Good. Okay, can I get another one next? So, how you What is the main difference in this setup? afferent arteriole that is smaller diameter than the efferent, just by making it smaller, if the pressure is maintained at such a high pressure, then it can really filter through all the 4 layers of filter. Yeah? Now as we go back in, I want you to look at the structure of the efferent and efferent arteriole. You'll find in your textbook and there is a size difference. Okay? You can go back in. No water. From now onwards, if anyone were to provide you an image and they don't tell you which is afferent and efferent arteriole, how do you tell? Okay? So imagine someone erase this away. How do you tell which is afferent, which is efferent? Okay? So I want you to forever remember that experiment out there. The afferent arteriole compared to the efferent one needs to be bigger. Or in other words, the efferent one needs to be smaller in diameter compared to the afferent. I want you to remember that because it's important. Once it is smaller in size, we can create and maintain this high hydrostatic pressure. If it's the same size, you saw what happened earlier on. That pressure is rather low, and actually, with every pump, you notice not much is being filtered through. Okay? So in this diagram, I hope it is a little bit clear which one is the afferent, which one is the efferent. And therefore, actually, if you look at your SLS, this section over here, unlabeled. Can you tell which one is afferent, which one is efferent? Okay, not drastically different, but I think they tried to show a slight difference. Can tell? Yeah? So this is an important skill to pick up also. And if someone were to ask you why there's this size difference, that is the reason why. Let's go back to this diagram. Are you able to identify all the various parts? What is the most challenging part to identify? Let's talk about it now. You can expect this diagram to come up again and again. So this is a good chance to ask some questions. If not, I'm just going to let you all be next time you encounter this image again. Yes, okay, come, let's go to questions. Yes.
The polo side is the blue color thing.
Which one? This one, is it?
No.
This one?
Yeah.
Okay.
Then isn't the pedicel the long?
Okay, so Hiran asks, if this is the podocyte, these are pedicels, correct? She's right. Then, what are all these small little things, right? Okay, so this is what it is. It is a matter of perspective. For those that don't understand, it's a good time to listen. If I look at podocytes from a certain perspective, let's look at it from this particular perspective, then you see that it has all its fingers coming out. Okay? I mean, sort of, okay, then the nucleus. But what if I'm looking at it from another perspective? What if I go and chop the fingers? And now I look at it from another perspective. Okay, after it's been chopped, you look like that, right? Okay? So if I'm looking at it, let's say my eyes are, I'm looking at it from this perspective head on, all I'm going to see is just this. Yeah? But actually each one of these represents a pedicel that is connected to a body of a podocyte. Following? Okay, so that is what you can try to gather from here. And therefore, what are all the gaps between the pedicels? Those are the slits, those are the filtration slits. Okay, so we must really try to make sense of this image here, because now it's in color, it's very nice. The moment it's not colored is when it gets challenging. You want to see a sample of a non-colored version, you go to section 4, go to question 4. Here's a real image. And all they provide is black and white. Can you tell what's what? So everything begins first with being able to do this page. Identify all of this. If you can identify all of this, I would say that you are quite, you're going to be quite prepared for quite a number of questions really.
Which section is
B.
Oh.
Yes. Oh, yeah.
The arterial, is it the one with the
Oh, okay, good question. Must the afferent arteriole always be the one on top? In biology, there is no on top or below this method of perspective. Because if I were to do a handstand, my head is now below my body.
Why is it like?
Yeah? So,
Why is it like?
the best way to determine is not by where it is by diameter.
Why is it like this?
Any more questions? Anyone has other issues in identifying certain parts? Okay, I've just one more thing that I noticed students have problem understanding. You see all these over here? Some students ask me, how come the glomerulus looks like that? Why do the capillaries look like that? Okay, the capillaries look like that because we are looking at the capillaries from a different point of view. Capillaries are long, right? They are like tubes. But if you are looking at it from a head-on perspective, then they are nothing more than just circles. Okay? So it's just a matter of perspective. Some of these capillaries look a bit longer. That's because I'm looking at it from a slightly slanted perspective. So it looks like you're looking at something rather long. But if you look at it head-on, then you look rather round. But if you look at it from the side view of capillary is very long. Siti, are you okay? Okay, you got a question, Siti? Wrapping around. Right? Okay. Siti asks, aren't the podocytes supposed to be wrapping around the capillary? They are. It's just that it's very hard to depict it from a cross-section perspective. So you may be wondering, how come if the capillary is like that, and then the fingers are like that? Is that what you're thinking? Okay? Because in reality, the fingers don't just branch out like that. There are also fingers on the fingers. Okay, so on each finger, there are more fingers coming out. Each one of these fingers will also interlock. Okay, it is crazy. So I show you a real image, microscopic image. Podocytes. And I want you to see that on each pedicel, you find more finger-like projections coming out. Okay, look at the podocytes here. Can you see that from each finger coming out, there are also sub-fingers coming out? So there are many perspectives you can see this, the way the podocytes wrap around the glomerulus. Okay, at our level, we don't need to differentiate whether it is a small one or a big one. You can just refer all of them as pedicels. Pedicels is just any elongated part coming out from the podocyte. I ever saw an image of a damaged one, and then red blood cells were starting to come out. asked, so far only focus on these cells here. What about all these cells lining the Bowman's capsule underneath the basement membrane? There's a name for them, but I do not need you to know the name. They are called squamous cells. FYI. Okay, any more questions with regards to this structure? Yes. The whole Bowman's capsule wraps like that. Yes. So all of the filters that we're talking about, they wrap around the glomerulus. Any more questions with regards to the identifying all these parts? You're expected to be able to identify. This is cartoon drawing. The higher level of this, it is at tab number 4, question number 4. You find a real photograph. Are you able to tell what's what if we give you a real photograph? This is the highest level we can go when we get you to identify the layers. Here we gave you the podocyte. We told you that this is the capillary. So then what's what? Yes. Say again. Earlier on, Shafika saw that there were extra descriptions, like the mesangial cells. These cells, you do not need to focus on them, FYI, but these cells are the ones that are found in between the glomerulus. That's all.
With the endothelial cell of the glomerular capillary,
Yes.
we know what's the function of that.
You know blood capillaries are made out of cells, right? Yeah. Blood capillaries are not made up of membranes. They are made up of cells. They are one cell thick. Yeah. So, do you have any more recess? No more. That means I'm not sure if you all managed to catch NKF. You all did not. Anyone got free start?
We saw you there.
You saw me there. I did not see you there.
You were eating.
I see all. Some of you all got the free kidney. I tell you, actually, their model, they went to the extent of in trying to be quite anatomically correct. You notice, for those that got it, they even make 3 tubes. One tube going in, one tube coming out, the big one ureter, and they make 2 tubes. One going in, one going out. Renal artery, renal vein. They actually try to be accurate to that extent. How big is your kidney? They even purposely make it almost the size of the actual kidney. So, this is a bit smaller than your actual kidney. Your actual kidney will be slightly larger. Okay? But it's quite nice. Okay, we are almost out of time. Let me check the schedule. 403. There's slightly more lessons. Okay, next week we have a 3-period lesson. That's where we will meet each other again. This is me trying to calculate out how many lessons we have, so that I don't shortchange you all. Yes.
Okay, Mr. Tan, right? Then from the joint here, right? How do you know what way it goes in? Like, does it?
What way what goes in?
Like, it enter the efferent, right?
Yeah.
Then it come on the efferent, is it?
Yes.
Then how do you know whether efferent is left hand side or right hand side?
I told you again, it's not about whether it's left, right, or up or down. You tell based on the size of the. Okay. In our next lesson, we are going to talk about reabsorption, selective reabsorption. We already encountered an issue earlier on. We tend to have a lot of good stuff coming out. We need to find a way to get them back. That's what our final lesson will be for. We need to learn how we are able to get back whatever we accidentally filtered out, like all your sugars and your amino acids. In the remaining time, may I get you to try out some of the practice makes progress, especially from A. Since we are done with A, you can try out number 1 and number 2. You can also go to part B to try out some of the practice makes progress. Gentle reminder, Jeanette, next week, right? I'm going to collect back next Thursday. Okay, so next Thursday, I would like to collect your term 2 review. The only homework, yeah? Okay, in reality, the only way you can do your term 2 review, some of the questions requires knowledge that I've not taught yet. But I would still like you to go and read and try. Okay? So that when you do come for the lesson, you actually have a little bit of knowledge already. Okay? Reason why we really just don't have enough time to wait. Okay, just try it first so that I have enough time to go through them with you in week 6. Okay, that's all. Yes, teacher? Yeah. You need to talk about which area last week. But you see how many marks are? Okay, that's all. Can we stop the recording? We'll end lesson.